begin with the first problem from chapter 11. Question number 24. You are considering a project with an initial cash outlay of $8,000 and expect cash flow of $20,000 at the end of each year for 6 years. The discount rate of this project is 10%. So, they have 4 questions. The first one is, what are the project payback periods and the discount payback period? And the second one is, what is the project NPV, the net present value? And the third one is, what is the project PI, the profitability index? And the last one is, what is the project IRR, the internal rate of return? So, let's begin with the first one. Find the payback periods by using the mathematical formula like this picture. Payback period is come from initial cash outlay divided by cash flow in. So, from the proposition, they have initial cash outlay at $80,000 and cash flow in each year $20,000. So that becomes 4 years. It means that the project have time period at 6 years, but they will pay back at year 4. It can show this project will acceptable because it's not lose the profit. And the first question also asking to find discount payback period. So, we can use the mathematical formula following this picture. Cash flow in divided by 1 passed with the K, that is a discount rate. And to the power by of n, that is a time. So, we will use the table like this picture to find the discount payback period at 10%. Let's begin with the first year. They have discounted $18,181.81. It's come from the mathematical formula that I already told you, which is $2,000 divided by 1 plus discount rate is 0.1. Then power by 1 because it's a year 1. And let's see the next channel in the table is accumulate cash flow in. First year is $18,181.81. Then let's calculate the discount in second year by use the same formula, which is cash flow in $20,000 divided by 1 plus discount rate 0.1. Then power by 2 because it's a second year, that becomes $16,528.93. So, let's see the next channel in the table is accumulate cash flow in the second year by use sum of the last year part with the discount of this year, that become $18,181.81 part with $16,528.93 is equal to $24,710.7. So, we have to continue do this process until 6 years. Then we found that at the 5th year, it's close to payback because this project we have initial cash outlay at $80,000 and for the 6th year, it's get the profit already. So, that is mean the discount payback period is between 5th year to 6th year. We have to find more specific by use the rule of T. So for the 6th year, we have cash flow at $11,289.48. Period of time is 12 months, and the cash flow for 5th year that payback already is $4,184.26. It comes from initial cash outlay minus with the accumulated cash flow of that year, that is $75,820.60. Then we can find the discount payback period following the rule of 3 by $4,184.26 times with 12 and divided by 11,289.48. is equal 4.4 months. So the answer for this discount payback period is 5 years and 4 months. So Let's move to the second question. What is the project net present value? By using the mathematical formula follow this picture, the net present value is confirmed cash flow out part with the cash flow year 1 divided by 1 plus discount rate, that is the key, and all of it passed with the cash flow in the second year and divide by 1 plus discount rate. Also do the same process until last year like this picture, so we have to calculate to find NPV by cash flow out $80,000 part with cash flow in first year $20,000 divided by 1 plus discount rate is 0.1 and power by time in first year. We have to do this process until the 6th year, so from the first year until 6th year is equal $87,105.22. Then we have to minus with initial cash outlay $80,000. So the NPV is equal $7,105.22. It's become the positive result, not negative. So we will accept this project. Let's move to the third question that find the profitability index PI. By using the mathematical formula following this picture, profitability index is come from the present value of future cash flow divided with the initial cash outlay. So the present value of future cash flow is come from the cash flow of the year divided by 1 plus with the discount rate, the key, and to the power of time or that year. Then will the next year following the same process do until the last year and the individual cash outlay. It means the cash flow out. So for this problem, the present value of future cash flow we already calculate in the first question in the table that come from the last year of accumulated cash flow, which is $87,105.22 divided initial cash outlay $80,000. The profitability index is equal 1.088 times. So PI is more than 1. That is mean this project is quite good and will accept it. Let's move to the last question. What is the project internal rate of return? By using the mathematical formula, which is the internal rate of return equal net present value that have the value as 0. So we have to find the percentage that make the NPV equal 0 by use this formula. Cash flow first year divided with 1 plus R and to the power of time, that is 1. And do the same process until last year, which is 6 year, then minus with I, the initial cash outlay. So from the proposition, we have R at 10% that make the NPV is equal $7,105.22. We have to find what percentage that make the NPV equal 0 by increase the percentage but still close to 10%. So we have to try by estimate at 12% first and calculate by using the same formula, which is NPV equal cash flow in $20,000 divided by 1 plus R, that is 0.12, and to the power of time following the year and past each year until 6 year. That equal $82,278 minus with initial cash outlay, which is $80,000. So R at 12%, that equal $2,208. It is still not equal 0. So we have to try another percentage that's still close to 12%. We have to try by estimate R at 13% and calculate by using the same formula, which in NPV equal cash flow in $20,000 divided by 1 plus R, that is 0.13, and to the power of time following the year and past each year until 6 year, that equals $79,950 minus with the initial cash outlay, which is $80,000. So R at 13%, that equal to minus 49 is still not equal 0. That is mean IRR will be between at 12% to 13%. So we have to use the rule of 3 to find specific IRR by one that comes from the digit. That difference between 12% to 13% times with $2,228 is the NPV that comes from the result of IRR at 12%. Then divided by 2,278, which is the result present value of future cash flow from 12% minus with 13%. That becomes 82,228 minus with 79,950. So result the rule of 3 is equal 0.978 and the answer of IRR is between 12% to 13%. That is mean 12 plus with 0.978. So the real answer is 12.978%.
For the question number 26, we need to calculate the net present value, profitability index, and internal rate of return for each project. So, project A, the formula of NPV to this project until last year, and is equal 49,336.8. So, initial cash outlay is minus 50,000 plus 49,336.8. So the answer of NPV is minus 663.2. So let's move to calculate profitability index, and the formula is present value of future cash flows divided initial cash outlay is equal 49,336.8 divided 50,000 is equal 0.9867 times. Let's move to calculate internal rate of return. 12% of NPV is minus 663.2. So we have to estimate because we have to find what percentage that can make NPV equal 0 by decrease the percentage but still close to 12%. If 11% is 12,000 multiplied 4.2305 is equal 50,766 and minus with initial cash outlay is 50,000 and is equal 766. So internal rate of return is between 11% and 12%. So let's find out of how much percent. 11% minus 12%. So we got 50,766 minus 49,336.8 is equal 1,429.2. And then we're using the rule of 3. 1 multiply 766 divided 1,429.2 is equal 0.535%. Then internal rate of return is 11% plus 0.535%. And the answer is 11.535%. So project A is negative NPV, NPI less than 1 and IRR less than 0. So let's move to the project B. Do formula of NPV do this process again until last year and is equal 53,448.30. So initial cash outlay is minus 70,000 plus 53,448.30. So the answer of NPV is minus 16,551.7. So let's move to the calculate profitability index, and the formula is present value of future cash flows divided initial cash outlay is equal 15,448.30 divided 70,000 is equal 0.765 times. So let's move to calculate internal rate of return. 12% of NPV is minus 16,551.7. So we have to estimate because we have to find what percentage that can make NPV equal 0 by decrease the percentage because 12% the answer is too negative. That's why we have to get it reduced. If 4% is 13,000 multiply 5.4172 is equal 68,147 and minus with initial cash outlay is 7,000 and is equal minus 1,852.7, but still negative NPV. But if T%, 13,000 multiplied 5.4172 is equal 70,420.6, and minus with initial cash outlay is 7,000 and is equal 420.6. So internal rate of return is between 3% and 4%. So let's find out of how much percent. 3% minus 4%, so we got 70,423.6 minus 68,147.31 is equal 423.489, and then we using the rule of T, 423.489 divided 2,275.11 is equal 0.186%. Then internal rate of return is 3% plus 0.186%, and the answer is 3.186%. So project B is negative NPV and PI less than 1 and IRR less than 0. Project A should be accepted because of fewer losses and have less negative NPV, and PI has higher index, although it is less than 1 and IRR has percentage that is closer, but it would be better. This project should be rejected.
Let's move to the last question, which is 12-14. As a part of its planning for the coming Christmas season, Criswell Motorsport is considering whether to expand its product line that currently consists of skateboards to include gas-powered skateboards. The company feels it can sell 2,000 of these per year for 10 years, after which time this project is expected to shut down, with solar-powered skateboard taking over. Each gas-powered skateboard would have variable cost of $40 and sell for $200. Annual fixed costs associated with the production would be $160,000. In addition, there would be $450,000 initial expenditure associated with the purchase of new production equipment. It is assumed that the simplified straight-line method would be used to depreciate this initial expenditure down to zero over 10 years. The project would also require a one-time initial investment of $50,000 in net working capital associated with inventory, and this working capital investment would be recovered when the project is shut down. Finally, the firm's marginal tax rate is equal 34%. For question A, what is the initial cash outlay associated with the project? As the information given, the initial cost of purchase of the new production equipment is equal $450,000. The incremental investment in inventory is equal $50,000. The initial cash flow for the gas-powered skateboard project will be the cost to purchase the new production equipment, plus with the incremental investment in inventory, when we sum it up, which will be equal $500,000. For question B, what are the annual net cash flows associated with this project for year 1 through year 9? The annual net cash flow for a project from year 1 through year 9 will be the revenue from the sales of new skateboards, less with the variable and fixed cash cost of production, and less with taxes, plus with the benefit of depreciation tax shield. By using the equation of operating cash flow equal net operating income less taxes and plus with depreciation, we can find net operating income by using this equation as follows. The net operating income is equal revenue less cost of goods sold, less with cash operating expenses, and less with depreciation. As the information given from this project, the revenue is equal to 2,000 units times with $200 per unit, which will be equal $400,000.
And the cost of goods sold is the variable cost per unit, which is $40 per unit, times with the number of units, which is 2,000 units. When we sum it up, which will be equal $80,000. And we will assume that the cash operating expenses are the fixed cost of $160,000. We need to find the depreciation by using straight line method. Depreciation equal depreciation basis less with salvage value and divided by the year of depreciable life. When we sum it up, which will be equal $45,000. Therefore, we can find the net operating income by using the information that we already found out and sum it all through this equation, which is net operating income equal revenue less cost of goods sold less with cash operating expenses and less with depreciation, which will be equal $115,000. So we can find the operating cash flow from this equation. Operating cash flow equal net operating income less with taxes and plus with depreciation. When we sum it up, which will be equal $120,900. For question C, what is the terminal cash flow in year 10? What is the free cash flow in year 10 plus any additional cash flow associated with termination of the project? As the information given, in year 10, we will add to this amount our recovery of $50,000 working capital investment. We can find it by using the equation of free cash flow equal operating cash flow, which is include net operating income less with taxes and plus with depreciation expenses and less with increase in capital expenditure and also less with increase in net operating working capital. When we sum it up, which will be equal $170,900. For question D, what is the project's NPV given a 10% required rate of return? Where an equation of K or a required rate of return is equal 10%. Therefore, we can calculate the project's value by using the equation as follows. When we sum it up, we will get $262,155. Since the NPV is greater than 0, so the project should be accepted.